What is science? There are so many facets to science that it is hard to summarize it in just a few words. But a good starting point is from the Eswatini curriculum for Form 1 science education. Science is an investigative method of gathering knowledge and the resultant body of knowledge generated. Observations and research of the physical world lead to theories and laws to explain how it works. Experiments are carried out to better understand the world and then make predictions about future behaviors. A greater understanding of the world enables scientists and engineers to build processes and equipment to benefit society. The universe is so complex that a scientist cannot be an expert in every possible field. So science is generally organized into three disciplines. 1. Physics, which is the science of matter and energy and how they interact. It includes astronomy, electricity and magnetism, waves, mechanics, subatomic particles, and many others. Then we have chemistry, the study of the many different types of substances and how they behave and combine to form other types of substances. And biology, the study of living objects such as animals, plants, bacteria, viruses, which are not always considered living, and how they are put together and act. Over time, as human knowledge of the universe has increased, the three branches combine to solve complex problems that require combinations of the three basic branches. An example is biophysics, biochemistry, this would be the combination of biology and chemistry, and physical chemistry, physics and chemistry, and up here, biology and physics. The role of scientists is to become an expert in one specific field and have a working knowledge of other fields that could impact their research. They document all their research so it will serve as a base for future scientists to add their contributions. It is not efficient to start all research again at the beginning. The goal of scientific discovery is to improve our understanding of the universe and our place within it. However, many times the same processes and equipment designed to advance science can cause harm to society. An important consideration for scientists is to consider the advantages and disadvantages of research, including its impact on the environment, animals, and of course, human society. With this knowledge and consideration, scientists develop acceptable areas of study and methods for scientific research. Research institutions have a system of checks and balances regarding scientific research and experimentation, especially when researching using humans and other animals. How do scientists meet the goals on the previous slide? First of all, they need to question everything. People used to think that the Earth was the center of the universe and the moon and the stars were revolving around the Earth. Scientists like Copernicus, Galileo, Brahe, Kepler, and many others questioned that idea and made detailed observations and measurements of the sky. They proved that the Earth and planets were revolving about the sun. Brahe studied the sky for over 20 years, every night, recording his observations in a very orderly fashion. The information was of such quality that Kepler was able to analyze it and describe the solar system. This was all done in 1609 without computers or telescopes. Shuji Nakamura developed the blue lighting emitting diode, LED, which revolutionized lighting. Light bulbs first created by Thomas Edison in 1879 are being replaced by LED lighting. LED lights are brighter, safer, more energy efficient, and last much longer than traditional light bulbs. Nakamura worked mostly independently for over a decade, building on experiments completed by previous scientists. He had many failures during that time, where he had to build new suitable equipment to continue his research. During an 18-month period, he worked 7 days a week for 12 hours each day. So scientists also have to be dedicated and willing to work very hard. Nakamura received the 2014 Nobel Prize for Physics with Isumu Agasaki and Hiroshi Amano for their work. Science and technology have brought many benefits and many risks to society and the environment. Sometimes both arise from the same technology. Decisions on the trade-offs between the benefits and risks have to be constantly made. For example, the study of the atom brought X-rays for medicine and nuclear power for energy purposes. However, nuclear weapons also resulted from this science. Quantum physics led to the discovery of the transistor, which revolutionized communications and computing. However, it has also decreased the amount of privacy experienced by individuals. Plastics contribute to health management in hospitals and safe storage of food, but their waste is long-lasting. GPS satellites use general relativity to account for the time interval difference between the satellites and the ground. Once again, privacy issues are affected by the collection of location data. Steam engines, turbines, and electromagnetic induction made distributed electricity available to many. Turning the turbines has environmental impacts due to fossil fuel burning, damming rivers, installing windmills, and nuclear power plants. The burning of fossil fuels made energy available to many, but also has an impact on the environment, global warming. Nuclear power plants are clean from the standpoint of carbon dioxide emissions, so they don't impact global warming. However, they produce long-lasting radioactive waste. Science careers can be found in 3 disciplines: research, which is examining the physical world to create new discoveries by increasing our knowledge about the world. This can be formed individually, at colleges and universities, industries, and in public and private laboratories. Education. It is important to train the next group of scientists by teachers who are knowledgeable about the various scientific fields and can impart their knowledge to their students. Applications. The use and development of technologies taking advantage of the research done over here and the education of new scientists. There are many different science careers. The following are just a few internet sites that provide summaries of opportunities and estimated salaries. And if you'd like, just go ahead and Google science careers on your own to find other sites that you can look at.